Welcome back to Attack 404. In this episode, we're going to be taking a look at Windows XP and incident response. And the reason why I'm starting with Windows XP is because a lot of organizations are still running Windows XP. And we're going to talk about the incident response process for an attack and malware. So let's get right into it. So there's going to be some times when you're going to see Windows XP used as a server. It's not uncommon. Some people will throw IIS on it, leave a laptop in the corner. It's a server. Run it. Most of the time you're going to see that it's a host that's doing something or has a service on it that's supposed to be providing some type of automation for the environment that they can't get rid of because legacy code, they're too cheap, they don't want to. Whatever the reason, you are going to come across a Windows XP box. So with that said, what we are going to be concerned with when we do an investigation on a box that's been compromised or infected is we're going to look at the software, the services, what types of persistence are on the box or what's auto-starting. We're going to look at the users and groups that might make that system interesting for an attacker to leverage and gain access to. We're also going to look at the shares what they have access to, meaning what other systems they interact with or how users interact with those systems. If they're throwing files on there via an SMB share and then they're grabbing files or executing them somewhere else, like reports that are generated and things like that. The other thing we're going to look at is the file system, and more so around what files are being created and modified. We're also going to look at the registry because that ties into persistence. Any USB or mass storage devices that are plugged into the box that might lead to a secondary infection where someone tries to get reports from the box or copy data to it. Malware gets copied onto that USB drive, and then what ends up happening is that device is then taken to another computer, and then the hope is that it's also infected in a modern operating system. Lastly, we'll take a look at any of the networking info and what that system has access to, where potentially that malware could laterally move if it has a worm in it, and then any routes that may have changed or have been added to the browser that might try to dupe a user into interacting with malicious domains rather than the legitimate ones, and then also any of the system information that we would need to close out the case or work anything that we need. Lastly, we'll also take a look at how a CM plays into this and what information we can leverage from a CM. We'll be using Wazza and ElkStack. I'll be installing both the agents on one system, and then we're going to be taking a look at what that data looks like when a piece of malware is executed. So I boiled malware down into a few basic categories. I'm going to explain that now, and then we're going to move on. And in the next set, it's going to get more and more technical because now we're going to be getting more and more hands-on. So all the stuff that I've been using in this presentation and in this example, I will give you access to on the Google chat, and you can play along with it and see if you can get everything working on your end. So OS, some malware is very specific to the operating system. What that means is it may be specifically designed for Windows 9X, it could be designed for DOS, it could only be designed for, let's say, the modern operating systems, but it might not work properly in 9X, it might not work properly in older versions of NT or XP. So in this case, we are picking on Windows XP. So normally how I used to write malware, it would be copy to a location, set up persistence, determine the user that you are. If it's an admin, then we're going to install into the Windows folder. If it's not, we're going to pick a location we can install to and set up persistence based on your permissions in the system. And then finally, what I like to do in my malware, when I used to write malware, is present the user an error. If you present the user an error, it's going to make them less suspicious that something that they clicked on isn't working in the way that they intend it to work. Meaning, if a prompt box is displayed and the program terminates, but before it terminates, it copied to another location, the user is simply just going to delete the file. More common is if you execute a piece of malware and it'll stay running in that one location, the user can't delete it. It becomes a little suspect. So I pivoted to write my malware in a way that it would install, present the error, copy to another location, the user agrees with the error, and then they are able to delete the executable after the fact. Now, when we talk about persistence, we're going to be talking about the services that we set up, if we're going to go the service route, We're also going to be discussing what registry paths we could use in the system that will also set up persistence. And again, this also depends heavily on your permissions to the system. Also going to talk about routes and communication and how this plays a pivotal role. Sometimes we'll install, and this is mostly adware, we'll install some type of proxy in your browser so that when you go to websites, your browser's hijacked, it goes somewhere else, and it's not the intended site you want. Some malware I've written looked for and searched for shares and then dumped the code onto the share in hopes that some network user would be going through that share and then potentially execute it. Lastly, we'll look at USB and how we can infect USB if in the event a user plugs in a USB drive, we can then copy over to it. It's not very difficult to write, and I'm going to be showing you this in multiple languages. And then finally, we're going to take a look at how the application itself calls home. When I've written malware, I've leveraged mostly WinSock. You could leverage that. You could also leverage a website. You could also have it just send email back. Or you could have it control the system through instant messenger, which is another interesting topic, which I don't think I could provide an example with anymore because Amy's been closed down. But that was a viable method in order to do that. So this is where we get into exactly how we're going to break down doing an investigation for malware analysis. And mostly this is going to be the incident response side of it. So the first thing we're going to take a look at is the file system. In some file systems, you can gain information based on the file system activity. Was a file deleted? Was it modified? Was it renamed? Was it created? I also have programs that I'm going to show you how to use that will also be on the Google Drive that you could run malware with and see exactly what's going on and how to divvy that information up. The next thing comes into play is, was it downloaded or was it sideloaded using a USB device? Downloads are a little bit more tricky because this, and I'll show you in a moment what that entails, but you could also use your CM to get these two types of information if you're actually logging it. There are certain Windows event IDs that we could use for file activity, so we'll be taking a look at those as well. The next thing that we'd be taking a look at, and I've written some detections for this in CrowdStrike when I worked at other companies, I'm not going to mention names, is what we could do in and around persistence. And if I find those documents, I'll probably post those too that you could take a look at and how I've orchestrated those methods of detection. So scheduled tasks are one of the things that we're going to look at and how to dump that. We're going to look at INI files because Windows XP was the pivotal moment when Windows started to move away from the 9X days and using INI files or INI files. Registry became a very prominent area where we wrote our persistence to. Startup files was another method if you didn't want to dump anything into the Windows registry, and I've done a technique where you drop a link with no icon and you basically call the link no items. So when they hover over the startup folder, it shows no items and they think nothing is in there. But the difference is that mine isn't grayed out and the original one from Windows is. So it takes kind of a keen eye to see that. Also, the services that are installed, how to go about dumping the services that are in there. Environment variables are another tactic that we could use where we could put commands in the environment variables that will actually run our programs. Another method that we could do is we could replace a legitimate file and rename it, let's say, cmd1.exe and cmd.exe, where cmd is our malware. And then the user will go to run cmd, it'll trigger our malware to run, and then our malware would then execute cmd. So the user doesn't really see anything outside of like a small egg. And then also you have DLL sideloading, which deals with taking a malicious DLL and putting it in a legitimate applications directory. And the way that Windows works and the way applications in Windows work is it's going to look for the DLL in the current directory and then go out to the system directory. And if it doesn't find it in any of those directories, it's going to present you a nice error message and probably tank. So you can do malware infections with a DLL sideloading attack, where you put an illegitimate DLL where a legitimate DLL would be stored. Next, we'll be looking at the network. And again, this deals with any routes and communication, GeoIP information. Is it contacting a high-risk IP address or country? Was the Wi-Fi changed? Did the system associate with a Wi-Fi point? We'll also look at Bluetooth and any of the Bluetooth devices that may be in the system or may have been logged. Then we'll look at the proxies and any proxies that were set up that could get the user to interact with illegitimate site. And then finally, any listening ports. And then under that, we're going to look at the browser history, and we're going to show you how browser history could be leveraged in order to find out if in the event that user went to anything malicious or downloaded something in and around that time. Finally, we're going to look at, and where we're going to start, and what everything is related to, is going to be a running program or service. Because running programs and services relate to all of the things that you see here. So if you have a running service you don't know anything about and it shows an open port and it's going back to an IP address, chances are it's going to point to a file. That file could potentially point to a run point, and then from that we can start doing our analysis. So let's take a deeper dive into this on the technical side, and let's get right into it. Okay, so there's a few things that I need to kind of go over before we get into the weeds with the whole auditing process. And this is going to come down to the way that Windows XP is set up, especially if you're not on the group policy side of things, and especially if you don't know much about the admin side of Windows. So if you just have a regular version of Windows, or the user is setting up a new box for whatever reason with Windows XP, I don't know why you'd be using it today. I mean, I could ramble off a few reasons, but none of them that would basically warrant using it. Legacy software. Who said that? But anyway, what we're going to do is we'll go into View, and we're going to scroll down to Use Simple File Sharing. If we have this enabled and we say OK, what's going to end up happening... Alright, shut up, temperamental. What's going to end up happening is if we look to audit anything, like in Properties, you'll see that there's nothing with security on there. And let's say, just for the hell of it, we want to audit the Windows directory. We don't really have anything giving us that option to do so. So in order to do that, what we're going to have to do is we'll just move this over here. We're going to go back into Folder Options, and then we'll go to View, and then we'll uncheck Staccato de bullshit. And then we take that off. And then if we go back into the C drive and we click on Properties, you'll see that we have security. And in security, we can hit the auditing tab, and then we can set up whatever or whoever we want to audit for. So with that out of the way, you will also see that I've gone ahead. I don't know if the options are still there, but I did it for... Let's get a little crazy. Let's go to the C drive. Any day now. And what we'll do is we're going to go to Security, we're going to go to Advanced, then we're going to look at Auditing. So what we could do is we can say the user that we're using. If we want to dial in specific things, we can. This is going to generate a hell of a lot of noise. So just to be brief, what I'm going to end up doing is I'm going to type my name in, and then what I'm going to look for is pretty much anything that's been deleted, if they succeeded or failed. Then we're going to look for write attributes, write extended attributes, create files and folders. We're going to look for write data. And I think that should be pretty much what we need to look for. So we're going to click on apply on that. We're going to click OK. So I'm going to go ahead and I'm going to delete this. I'm going to pretend we didn't see it. And then what I'm going to end up doing is I'm going to go back to Windows. And I'm going to delete this as well because we're going to pretend we didn't see it. So I am going back and doing this in multiple segments because I had to splice a bunch of stuff together. And it's already on day 3 that I'm doing this. So when I did say that there would be some type of resource depletion in your system when you enable all of those auditing options, this is what I'm talking about. So one of the other options to audit that we are going to take a look at before we play the role of the naive user is we need to understand registry edit and the auditing involved in it. So if we go into the registry edit and we click on, in this case it's HKey local machine, if we click on permissions and then we click on advanced and then we go to auditing, you see there's all. I pretty much put the username already in there. The next thing that we're going to end up doing, and this is similar to the previous section where we did the file auditing, is we're going to have to look at GP edit. And in GP edit, we need to go to Windows settings, security settings, and then in here we're going to look for local policies, and then we're going to go to the audit policy. And in the audit policy, we're going to enable everything in here that says success and failure. So you can see if we click on this, there's success and failure selected, and that should normally give us whatever the hell we need. That'll tell the system to start logging when and if something is changed or an object is accessed and stuff like that to give us an audit trail. In systems that don't have this enabled, there's different ways that we could find when files were created, modified, and all that other stuff, and we'll pivot into that method first, and then we'll use the options that we enabled in the system to go back and look at what the security logs look like if in the event we have that enabled, so we could get a better timeline of what happened or forward that to the CM or whatever we need to do. So we're going to take a look at doing the file detections first, and then we'll start pivoting back to the event viewer right after this one. So in this example, what I did was I went ahead and created a Visual Basic 6 application, which at the time most of the malware that was created was mostly Visual Basic 6 and Visual C++. Very rarely would you see a ball-in piece of malware, well, at least from my perspective. And I will be providing the source code for this application and the BAS files. This is a kind of hat tip to the AOL Punter days. And if you guys are looking for some nostalgia with the BAS files from back in the day in Visual Basic 6 and 3, I have a good majority of them. And if you want, drop me a line and I'll gladly share that in a zip file so you could feel a little nostalgic. So the whole point of this application in a very basic way is to demonstrate what a piece of malware would do on a box, and then how we could go about responding to it. The scenario that I am creating at this moment in time is specific to a user calling and saying, I think I did something wrong. Chances are that's ever rarely going to happen, but if it does happen, you kind of have a perspective on how you could pivot, especially if it's a legacy box. You will probably come across legacy boxes that people will forget. It probably won't be a user, but this will help you build on how to investigate an attack or a piece of malware getting on the box. Also, I'll probably be creating somewhere down the line another version of this where the attacks happen weeks prior and we have to go in and gather information when and what happened and all that good stuff. So let's jump in. So in this case, I'm going to modify a file, and you'll see when you run the application, your own virtual appliance, it'll tell you everything went fine. Yay, we're infecting ourselves. So in this case, we're going to start search, and what we're going to do is go to all files. We're going to click on the advanced options and make sure these 3 options are checked. If not, fine, we'll look at the hard drive like it's Galileo and just stargaze and not return anything. So we don't want to do that. The next step we're going to do is, in the advanced options, we're going to gun for when it was modified. We're going to specify the dates between today and today, because that's when the user called, right, in a perfect world. And then what we're going to do is we're going to either go with modified, created, or accessed. So if we want to look for modified files, we are either going to do modified or accessed. So we'll start with modified first. These we could ignore because I've basically modified these. I love how my scroll doesn't work. System INI might be interesting, and I'll explain that later on. We're not going to pay too much mind to that because we didn't get that far ahead. So would WinInit dot. Let's try this again. So would win.ini. And nugget of info is that these 2 were legacy run points for malware. So keep that in mind for now. If these were environment variable files, I would be a little suspicious. Sam.log might be a little suspect here. So we'll start looking at the obvious. We did see auto accept bat, and it is 1, so we're going to look at the file. and we see that this was modified today, 2:06 a.m. So we would normally grab this as a piece of evidence, and this might actually contain where an executable might reside. If it doesn't, that's fine. The next thing that we're going to end up doing is we'll probably create a file, because malware has to create a file somewhere. And then what we'll do is we're going to look for created. Normally when you're dealing with created files, you're going to look for exe, or you're going to look for com. If this doesn't really return anything, let's go with access time. And there is a lot of files that come back. So I would probably grab the hashes of all of these and bulk upload them just to see if they were seen in any threat intel, and if not, I would probably pivot on what's running at that current moment in time and then do an analysis like that. If not, we would probably pivot to any of the startup locations that might use registry or anything of that nature. So in this case, what I'm going to do is a little magic. So we're going to write to an INI file because we need that. And if we reach dead ends with anything that's running, and we only see, benign malware in the search results and nothing else, what we could do is head to either sysedit and go with the system INI first and see if we see anything suspect. We don't. We go win INI and we look for, I think it's win and load. There it is. So in win and load we see pawnage exe. If we go back to our search, okay, we see, nope, that's ping. We see that this is in the C drive, and we see the file here. And if we want to get crazy with it, what we could do is we could grab a hash of the file and see if we could see that throughout the networking appliances that we have, or if anyone downloaded it. So now we have our binary. We can, if this is not running, store this as evidence, so we could throw it into a malware lab and start looking at it there. Next thing we'll probably do is in the system configuration editor, or if we want to load the file itself, we would take a screenshot of what's loading here. If in the event the malware decided it was going to load and modify system INI, and we look in sysedit, normally we would see boot, and I think it's shell. For some reason my application's not writing to it. I'll revise that later, so it'll look like boot and shell. And in this case, if I'm not mistaken, it's C:\Windows Explorer.exe, and if there's malware on the box, it would probably do, and if it was someone really trying to hide, they would dump it all the way to the side, so that when you looked at it, there's nothing wrong, but it had all of that. So keep that in mind when you're investigating Windows XP boxes and 9X, because this would normally take place. Registry is a little bit different. We might want to do some auditing, but just as a golden rule, I'm going to show you where to look. So we're going to write to the registry, and we'll pretend that that didn't happen. So we're going to do HKey local machine, software, Microsoft, Windows, current version, run, and run you'll probably, and here it is right here. You get run, and then anything under run. Run once EX, run services, any of the run paths, you're going to look and you're going to scrutinize the shit out of it, because chances are you're probably going to have malware writing to it. There's also, I believe, a WinNT version of this, and if memory serves me right, there should be something with Explorer that can also be written to. If you see anything with Explorer, they may have removed it in God knows whatever update, because again, it's been a long time since I've messed around with any of this. Windows NT had, I think it was shell explorer.exe, and malware would normally either write to that path, or it would load 2 executables or just the one, and then when their executable was loaded, it would then load the explorer.exe, so your shell popped up when you log in. So that's some of the locations in the Windows registry that it would load from. I'll put a document together that shows you exactly where you need to look as well. That's a cute little PDF where you could look, but most of your malware will run here. So with that, the other location that you have is a startup. I'm not going to really talk about scheduled tasks because that's a whole other beast, and I'll just put out there that you should be looking at scheduled tasks. I know I briefly mentioned this before I started doing the edits, and I had to come back and get another version of this edited for you. So one of the things I touched on was scheduled tasks and what services you have that are running. When you're doing an incident response on a system, especially when you pull from netstat and you're seeing some weird communications on the PID, what I would like to do, or what I do in my incident response process, is I would do task list, if that would type right, and I would grab this with an output by redirecting this way, and then, you know, date, time, whatever the case is. The other thing that I would do is I would run a SC query just to see the services that are running. So if we run this, and we do services.log, we could open it up and kind of gain like a snapshot of what's running in the system and try to compare that. And when we're on the box, what we would also want to do is look at, that was loud, the services in administrative tools, and we'd kind of want to go through the list as to what the hell is loading and take screenshots of all of this and the states. So we would start a screenshot from here to here, and then label them screenshot 1, 2, 3 services, whatever we want to do. This will give us an idea of what is also loading that we might not see in startup or any other locations. Scheduled tasks, on the other hand, would require that we do the following. And you'll see that there's no tasks scheduled in the system, and if we want, we could do, I'm going to create a scheduled task and show you what that looks like. So we'll say we're going to start this on pawnage daily, and let's say we're going to start at, let's say 5 p.m. Actually, you know what, we'll set it at 7:30 because we know most people might be on the computer at that time, and we'll do it every day, and we'll start it from this current date and time. Actually, we'll do it without a password. Shouldn't need any of that. So we have a scheduled task already set up. We see it in there. This is one of the places that we could look for it. If we go back to the command prompt and we run that command again, you'll see that we have a scheduled task already created. So what we could also do is go into this, double click it, and see what this scheduled task is doing and what it might be executing. In this case, we see it's in Windows and it's executing pawnage, which conveniently is this application that created it. So we could go back in and we can either search for that in the registry like we did before, or correlate it like we'll do with the audit logs. We'll see that as the video progresses. So if we look at the startup locations in Windows, you'll see that pawnage is in here. Now, a really good attacker won't name this pawnage. What they would do, let's do explore all users because I'm lazy. What they would do is, let's say we'll create a link. We'll do that. We'll hit next, and then we'll do the file name. You'd be able to change the file icon to a blank, and then what would end up happening is when you go to the Start Programs menu, you'll see it says no items. So you could, if we remove this one, and it's got a blank icon in it, you'll see no items and think there's nothing in there. That was another technique that I used to use. write a blank icon to the file itself, and then the user would go in and hopefully skip over it. But you'd want to open up the start menu items like I did here and make sure that any of the items in there you start to scrutinize, and then you use that as part of your investigation. Hide from Task Manager would happen in one of two ways. Either they would hide with the Control-Alt-Delete, or they would hide it from the task switcher. This cannot be done at runtime. It has to be run from in the application itself. Not that you're going to be coding malware in Visual Basic 6, but if you go with Show in Taskbar and you set it to false, it won't show up when you do this. But you'll see it here when I'm doing it now. Another technique was, and this is Windows 9X, it's not going to work here, is we can hide from the Task Manager, and again you'll see it there, but if we did Control-Alt-Delete, you'll see it here, but in the old versions it only showed a minimal dialogue that you could select and, you know, end task on stuff. I'll splice that, what that looks like in somewhere in here. Block Control-Alt-Delete would block the user from sending Control-Alt-Delete. Unfortunately, I couldn't get the VB6 code working for it. Let's do virtual keyboard. I'd actually have to be on the box and sending this over to see if it works, but I have the API functions that disable the Control-Delete. So if we did, we'll do Control-Alt and issue the delete, you'll see it's working here. So if you're issuing Control-Delete on a remote session and it's not coming up and it's Windows XP, suspect malware. Another thing that they would do is, you see that we ran Task Manager before. If you see anything like this, poof, gone, Mason Kreskin, doesn't come up, what's going on? It's not an environment issue, you probably have malware on the box that's looking to hide. Reason being is that it doesn't want to be removed. Now, this can also be said for registry editor and sysedit. I didn't design it where it closes the window on this, but if we go back to the source code and we look at, I think it's this one, you'll see that we want to close it. And if we want to modify some of the code, we can do regedit and we can close that, or we can call a freeze so that it disables the we can freeze the window here so you can interact with this, but you can't interact with the windows here. That was another technique that malware would use to stop you from trying to remove it from the system. So if we unblock Task Manager and we go back and we run it again, oops, you'll see that it stays open. Oh my. Who would have thought? So another thing that we have to look at is what happens when executables are listening. So based in your environment, and if we do a netstat tac ANO, and I showed this in the first video that I've shot with the attacks on web applications, and command prompt is disgusting in Windows XP. You'll see that you'll have 135, 445 is open, all that cute stuff. This again is going to fall back on your environment and what approved applications are and what ports you have for those approved applications. So if you start seeing weird ports open, chances are the user did something that they shouldn't have been doing. So you see from this example, I'm going to go to my desktop and we'll do netstat ANO, and we'll do normal, if I could spell. And you see that this pops up here. It's all cute, fine and dandy. Let's do 20 because we're blind as shit. And then I'll move this to the bottom portion of the screen. And then we'll go through it like good boys and girls. So you see all boring ports. I'm already seeing something that is residual from the last reboot that didn't go away. So I'm going to reboot really quick, and then we're going to continue shooting. Once all that's done, we're going to be the naive user, and we're going to go and we're going to basically click on this, and let's just say we're going to go back to sometime in the 90s. Anna Kournikova, Melissa Virus, I don't know, some type of nudes came down, we look at it, oh my, we want to look at it. So we're going to click on registry. There's no nudes. Who would have thought? So what we're going to end up doing is in the event viewer, we're going to go back, and what we're going to look for, I believe it's 560. And what I'm going to end up doing is I'm going to kind of do a brief pause and come back to this so I can show you exactly what this looks like. Alright, so things got a little wonky. It's actually 562 that we're going to be looking for, and what I'm going to end up doing is clearing the security logs. And then we're going to look at the time. It's 11:50, so what we're going to do is we're going to do registry. It installed. Yay, nice, fine, great. Then we're going to go back to 11:50, which has a lot of crap in it, and we're going to look for 562. So Windows was being a fickle moron, and it took me a hot minute to get everything hashed out. For some reason, either I'm having problems with the event viewer or some funky shit's going on. But anyway, when we click on the registry button to make it right to the startup location in the registry, what's going to end up happening is it will create the key that we need for it to start up and set up persistence. And then we can see that the binary, if we look for event ID 560, I believe it is, right here, we can see that something wrote to the run path in the registry. If we want to cheat and we're dealing with logs, what we could potentially do is copy this, and you'll see that we executed this from the C drive, which I'll show you that now. Right here, so wherever you're executing the image from, that's where it's going to pop up. So if we take this right here, shut up. If we take this here and we copy it, Control C, and then we click on security, we right click it, and then we go to find, and then we pop this in. You'll see it highlighted this, and we can start looking at what applications wrote to the Windows registry. And then if we want, we can copy this out, and we can basically bring this into a notepad. I can't stand the Apple keyboard. And then you see a larger version of what's going on, so you see where it wrote. You see the image file that wrote to it. And you basically see the access that it pretty much provided. And you also see the user that we were auditing for this. So when you're doing your investigation and you're investigating malware, I would take a screenshot of this. We already know that the run path was modified, so if we go into the registry, we can take a look at... Let's get a better view on this. We can kind of take a look at what applications are here. And as I've noted before, if you don't see a path as to where this is, chances are it's either in Windows, which you see it right there in the Windows directory, or System32 directory. Ever rarely will you see it that it's going to call from the C drive. But also look there as well. And then you might want to take a look at the environment variables. So to check on the environment variables, we're going to right click on my computer, we're going to click on properties, we're going to hit advanced, then we're going to say environment variables. And we'll probably take a good hard look at all the environment variables that are set, just to make sure nothing changed or was added. We may also want to click on them and make sure in Visual Basic, and I'm not saying you have to go crazy going back and forth to this. What you could do is, if you really want to go ape shit, you could do this. Hey, it's been a while since I coded in this language, so let's do 200 and whoop. I think we have to set multi-line here. That's probably the... Yep, there it is. And you could basically grab this. You want to take out the text 1 in there. You'll basically grab all of this and put this into... of course it's not. Grab everything that you have in here and then load this into a text file so you can see what the hell's going on. And pretty much dump this as evidence if you need to come back to it if they're going to re-image the box. But that's how you would do this in Visual Basic. And that's how you would grab the environment variables. One other segment that I do want to bring to your attention is what we would kind of look at when we are investigating the browser to see if the user had actually downloaded anything. And I do believe that if you go into... In this version of Windows, there's no real download location. Sometimes it's in the C drive. Sometimes it's God knows where the user decided to put the downloads. You can see I'm going through this. It's nowhere to be found. So what you can do is in certain browsers, Control-J, you can find out where they downloaded an application to. In this case, it's the desktop. You could also look at and grab screenshots of the websites that they've gone to. I have tools that do it in the modern operating systems that I'll be providing that really don't do it here. And gathering this information or screenshots where they potentially visited can kind of sort of paint a picture as to the likelihood that they've downloaded this from a browser session. Another thing you might want to take a look at is setting up a screenshot of their downloads. And this is respective for all the browsers. Because let's say they did install tight VNC on this box and they're looking to data exfil somewhere along the line. This might not come up as malicious. So you'd have to fall back on your CM in order to find it. But if it's still in the desktop, or on the desktop, we could go to Open Containing Folder. In this case, it's not there. If we decide that we're going to look for any of the other applications, which this one I'm pretty sure isn't here either, we could navigate to the location where they're downloading stuff and pull all the hashes from that location. And the file creation date and times would give us a roundabout time frame when they've visited something that we could kind of tie to the user and use that to pivot into the CM. So I'm going to cap the video with this. So we covered a little bit of information about how malware gets on a box in Windows and how to do a basic investigation for incident response. We've gone over the auditing, we've gone over some of the run points, and I'll put a lot of that in the description. If you need or you have any questions, hit me up in the comments. I'm going to cap this video at this point in time because we still have to take a look at what an attack looks like in Windows XP, and we'll continue that in another part of the series. So if you like the content, like, share, and subscribe. If you have any questions, comment, let us know. If you want to connect with us on X or Twitter, you have the links. We'll see you there too.